Okay, so 16.8, your homework. They wanted to see if there was a statistically significant difference between shift and flex status and whether or not people are satisfied or dissatisfied with their jobs. So this was the observed data. These are all your observed values. The first step in the chi-square is you have to do the expected values. What should we see in these 4 substantive cells if there's no relationship between shift and satisfaction? So that's your row marginal times your column marginal over n. Did you all understand the marginals from the video? This was, you guys had this video lecture, right?
Right.
Okay. So what I usually do is just go start in the northwest and go clockwise. So these are all of our observed. Our expected for this cell in the northwest would be its row marginal of 249 multiplied by its column marginal of 380 all over the n of 611. And when you multiply it out and divide it, I end up getting something, if you round to a whole number, about 155.
So we're not supposed to take it to 2 points?
You can, and that's fine. It'll be more precise, but to make it easier, just do it to this full number. So we observed 194. We should expect to see 155 roughly, if there's no effect between job status and satisfaction. So if we go to the northeast cell, for flex hours dissatisfied, we observed 55. Yeah.
When I was working this last week,
Yeah.
I noticed that that number plus that number equals 249. That number plus that number equals 380. Does that always work out that way, or does it just have to be that way?
The expected numbers?
Right. The expected numbers, when I add my expected numbers up together, they equal that total number.
I don't know if they have to. Oftentimes they will.
Okay.
I'm not sure if.
Okay, the only reason I just asked you because I'm like, I figured out that one and I already knew what the other ones were.
Yeah, well, I'm not confident that it's a perfect.
Gotcha. That's what I was asking.
Yeah, but it tends to work out, at least in the homework problems, that easy. But I don't know if always. So
Okay.
yeah, just run through them just in
Got it.
case.
Too easy.
All right, so for this cell, row marginal is 249. Its column marginal is 231 over 611. And I got 94, roughly, for the expected value for the northeast cell. So 94. Continue going clockwise to flex satisfied 176. The expected value should be its row marginal of 362 multiplied by its column marginal of 231 over 611 the n. And I get about 137. Depending how you round. So we should see 137 in that cell. And then the final cell, the southwest, we observed 186. What should we expect to see? You take its row marginal of 362 times a column marginal of 380 over 611. Got about 225. Questions on getting the expected values? Now to determine if there's a statistical significance, you have to calculate the chi-square statistic. And what you do is you take the observed value minus the expected value, square the difference, divide by the expected, do this for all the cells, and then add them up. So going clockwise again, starting northwest, we observed 194. expected 155. Square that difference and divide by the expected of 155. So this ends up being 39 squared over 155. And I get 9.81 when you do the math out. Going clockwise to flex dissatisfied, we observed 55, expected 94. Square that difference and divide by the expected 94. And you should get, what's that, a negative 39 again, right? 39 squared over 94. You get 16.18. Keep going clockwise to the southeast. We observed 176, expected 137. Square the difference and divide by 137. It's another 39 squared over 137. We get 11.1. And then go to the southwest for the last cell. We observed 186, expected 225. Square the difference and divide by the expected of 225. And 39 squared over 225. 6.76, close. The last step, just add all these up. And I get roughly 43.85 is our chi-square value. Rounding will affect a little bit. Does anybody need to see this again or got lost in the process? All right, to determine if this is statistically significant, you go to your table in your back of the book for degrees of freedom. Number of degrees of freedom is number of rows minus 1 times number of columns minus 1. And these are substantive rows and columns. So 1, 2 rows, 1, 2 columns. So 2 minus 1 times 2 minus 1 is 1 degree of freedom. And for 95% significance, we're looking at what value that we want to meet and or exceed. Yeah. Our critical value is 3.84. And obviously 43.85 is greater than 3.84. So yes, there is a statistically significant relationship between shift status and satisfaction. If you look at the numbers, you can pretty much just eyeball it and see that flex status are more satisfied than shift status. But you could go in and do the percentages, divide 186 divided by 380, 194 divided by 380, and then do 55 divided by 231, 176 divided by 231. It's pretty easy to see here that it's flex driving the relationship, and they're more satisfied. Questions on the written part of the homework. Okay, the SPSS, you didn't have to do any kind of calculations. A few people did. All you had to do is look at the output. And so for the first test, they wanted you to look at the effect of HOAs and tennis courts. All the no's were coded as a 0. All the yeses as a 1. And the cells, can somebody repeat those? For non-HOA, no tennis courts, it's 0, 0.
36.
Let's repeat that one.
No.
Let's see. Yeah, it's... Okay, yeah, I was looking for the wrong one. 36, 1, 30, and 2. And your Pearson chi-square they gave you was 0.519. So they give you a chi-square value, 0.519. This is looking at if HOAs are more or less likely to have tennis courts. Non-HOAs, 36 said no, we don't have. One non-HOA said yes. HOA neighborhoods, 30 said no, and 2 said yes. But that difference is not statistically significant because your chi-square is 0.519. You need that 3.84. If you look at the ASIMP SIG column, it gave you a value for this Pearson chi-square of what, 0.4? 0.471. Remember, we want this to be less than or equal to 0.05. So these two variables, HOA and whether or not they have tennis courts, are independent of each other, no statistically significant effect. Questions about that? City meeting.
I did the math. Well, I wasted it.
Yeah, you didn't have to do that.
I did too.
The next one was, do these types of organizations differ on whether or not they attend city meetings? And the numbers, somebody read them for me. Thanks. 7 and 29, 15, 16, and your chi-squares
6.327.
6.327, and it's 0.012. Okay. So this is looking at whether or not homeowners associations are more or less likely to attend city meetings. The total is 36, 31. So the HOA neighborhoods, they're coded 1, so 15 say no, we don't go to city meetings. 16 say yes, we do. So roughly 50-50. Non-HOA neighborhoods, 7 said they say no, we don't go, but 29 said yes. The chi-square statistic is 6.327. It's obviously greater than 3.84, so it's statistically significant. Or you look in the ASIMP SIG column, 0.012 is obviously less than 95% significance. So yes, there is a statistically significant relationship between HOA type and attending city meetings. I don't think you had to go further, but if asked what are HOAs more or less likely to attend city meetings, who's attending the city meetings? Are they HOA neighborhoods or non-HOA neighborhoods? Non. Because if you do the percentages, here's your HOA neighborhoods. About 50% each way are saying 50%, almost 50% are saying no, and almost 50% are saying yes, okay, roughly. But that split is much larger for the non-HOAs. You've got 7 out of 36 saying no to 29 out of 36 saying yes. 29 out of 36 is, pull up the calculator and see the percentage.
76.
I'm sorry?
I think it's over 76%.
29 divided by 36. Yeah. It's almost 81%. This is almost 9%. So you do the percentages, you see it's the non-HOA neighborhoods driving that relationship. Surprisingly, non-HOA neighborhoods are attending city meetings more than HOA neighborhoods. Questions about that one? And then the last one was a t-test to show you what you have to do depending upon how your dependent variable is coded. You see the two chi-squares, the dependent variable, no or yes, it's categorical, so it's a nominal level dependent variable. When we did the t-test, which was I think homework problem number 4, you were looking at how the independent variable of party, Democrat or Republican, affects the number of health bills sponsored. So that dependent variable is interval, so that's why I put that on there so you can see the difference between a t-test and a chi-square. And so they gave you the means. A value of 0 was for Republicans. The means table, they gave you what, 0.13? So Republicans on average sponsored 0.13 bills. Ones are Democrats was 0.63. Okay. So that looks different. Democrats supporting more health bills, and you could probably hypothesize the reason why. This 0.5 difference, is it statistically significant? Are Democrats more likely to sponsor health legislation than Republicans? Well, you look to your t-value, and it ended up being what, negative 18.326, and under the sig column, it's what, 0.000?
Yep.
So yes, it is statistically significant. With thousands of degrees of freedom like they had, your critical value would have been 1.96 plus or minus. Negative 18 is obviously greater. Or you look at the sig column, that's sort of 000. Yep, statistically significant. The Democrats do sponsor more health bills than the Republicans.
I just have one question. So if we were to do the t-test, like all the numbers were there, but what would have been the number for the population mean?
They're doing a test of, they're comparing 2 samples, and we haven't covered that.
Okay, so
Yeah.
good, because that racked my brain
Yeah.
and I finally said, screw it.
Yeah, if you wanted to do that comparison, you'd have to come up with one on your own and then compare Democrats versus Republicans. But this is comparing Democrats and Republicans.
Okay.
And your book discusses it, but it's too much math.
Okay.
I agree. Too much matter.
All right, other questions on the homework?